So please welcome the two speakers, Professor Shinkyu Park from the Electrical and Computer Engineering Department and Professor Charlotte Hauser from the Bioengineering Department.
Thank you particularly to the organizer to have me here. I have a very different background than most of you. So thank you to Professor Feron and Michael Berumen and Professor Shinkyu Park, who's by the way also speaking with me, as you have seen here on the title, on the first slide. So it's, I guess, now switching gears from aerospace and technologies now to corals. I wanted to give you a little flavor by first showing you a little bit what's all about. And one thing to maybe just have no wrong expectations. I was asked by somebody if I would print live corals. We are not printing live corals. I do in tissue engineering. We also cannot print live humans, right? Live corals I cannot print, but we can print something which develops to live corals. So that's just for having wrong expectations not set from the beginning. With saying that one, I give you a little small video which we have included, which tells you about what is all about corals. And I don't even have to speak too much because you can read it. What's happening over here. And just imagine that water is 80% of the earth. So, and corals is not 80% of the water, but it's also a very important part of it. And that's what happens with coral. They bleach over time. You have heard about coral bleach, I guess. I myself, by the way, not even a marine biologist. So we have at kAUST developed something to help to prevent this bleaching and this destroying of the corals. Why? Because it has not only a beauty aspect, but also an aspect in terms of environment, fishing, a lot of important things, and to make the environment better and to keep things in a way which we would like to maintain. So we have developed some of his colleagues here at kAUST, which we call Maritexture. And this is something, what you do basically with corals, you can grow them from small, and when you start, you would, so it's a very quick overview. Printing is included, spraying on things to protect them. Then later you take small, like with plants, small little fragments on the printed structures, create new ones, and then you wait and put them out in the field. So this is just a little flavor, very quick, what's happening. So what can we do here, or what we decided to do from the biotechnology and bioengineering prospect? So we offer solutions as of a so-called hybrid fragmentation process, where we use novel materials, printing technologies, novel robotic technologies, etc., in order to speed up this process, which would otherwise take probably centuries. So this is a hybrid fabrication process. Also, we explore biopolymers, which we developed in the lab, and for enhancing coral growth. Then look for the fabrication of coral structures, and that's where the major subject of this talk will be here, how to use here robotic technologies. Also, we have something else developed, like bioadhesives, in order to, because the whole process, as you have seen, is not only printing structures, but also including really then living material onto it, gluing it onto it, and then seeing in the test, which is in tanks or in the field later, if we are successful. So we had published something, so the time is really short here, which you might read about it. So this is actually something which we call 3D Cora print. That principle, a sustainable and eco-friendly process through 3D printing and fabrication. And now let's see how the robots comes in. So that process has actually 3 major steps. So you have to replicate the material, the corals, and meaning harvesting it here, scan it, make a model, a CAD model, then after scanning, and then use this one for the printing. And there, the idea came in that we use better robotic printing. And this is Professor Park, who will talk about this in more detail, how that really is functioning. So this is just the overview. And we have another technology where we print molds in order to speed up a process because printing takes a little while. And we also are, particularly in my lab, is very strong in material and adhesives, so in the material properties, and finding eco-friendly, sustainable material to speed up or to help to make this process successful. In the end, when you have all this done, the printed structures, you do what is called microfragmentation. You basically, from the healthy corals, big structures, you cut little pieces, put it on, glue it on the printed structure, and then seeded it, and then do a field deployment. That is obviously then the final proof of concept. So in order to get a bit more knowledge of what's going on and what is the advantage of using robotics for this process, I will hand over to Shinkyu, who will have more to say about this one. And I have to say, I'm really happy to have him in the collaboration.
All right, thank you so much. I'm very glad I'm standing here, and welcome to kAUST if you are coming from outside the kAUST campus. So I'm going to continue this presentation and telling you more story about the robotics side of our collaboration. So the reason why we are interested in building the robotic 3D printing system is because, robot, it has a high degree of the freedom. So essentially you can move the robot as if it's your arm, and imagine your arm is holding a 3D printing pen. So you can essentially use the system in order to print most likely any structure you want. So the reason why we are interested in this system is coral model is very, very complex, and sometimes it can be large scale. So we don't want to do some 3D printing with a regular printer that is actually contained in the cage, or it can do bottom to up 3D printing method. So we want to overcome some of the limitations we have faced with a conventional method. And the other part is we are also thinking about expanding the 3D printing capability. For instance, we are looking for a different means of manufacturing technology that is already developed in the industry, such as additive manufacturing, subtractive, and also we can do the assembly with a robotic arm as well. So you can imagine if you can combine these three technologies together, we probably can do more than what we have used to do with a conventional method. So to give you a brief idea of how we build a system, so it has a two main parts. One is a software pipeline, and the other is a hardware integration. So software pipeline, we build a software that allows us to put in the 3D model of the coral, and it does the analysis and try to build a toolpath that has to be used to control the robot in a way that the tip of the nozzle of the 3D printing part needs to follow this predefined toolpath. And also the software generates the control signals for the robot to follow the predefined toolpath. So once we have this software, we integrate into the computational unit that is connected to the hardware robotic system. And for the robotic system part, we have an extrusion system, which is also integrated into the control system of the robotic arm. And we are actually controlling the motors on the robotic arm at the same time, the extrusion system. So we can actually control the speed of the 3D printing, also the speed of the arm movement. And the rightmost figure is one of our samples. Our students actually did a great job in doing the demo of the 3D printing. So the screen over there is actually showing some of the process. It's a fast forward video demonstration. So I believe it's like a 3 to 40 times faster, 15 times faster. So it takes about 1 hour to print out a small piece. But we are imagining if we can use the multiple arms, different means of 3D printing technology, we can definitely expedite the 3D printing process. Of course, we didn't start with thinking about just using the robotic system, but we start with the core part of how we can actually build a coral structure that can be used to grow the live coral frag segment. So our starting point was looking at the 3D model of the real coral and do the 3D scanning. We did a printing of the 3D model with a conventional one and tried to see if you can use a mold, use the silicon material, and pour the CCP is a bio 3D printing material that's compatible with the growing coral. So this is the earlier version of our work. Of course, later we found a way to bypass molding process. So instead of making mold out of the 3D printed part, we directly use the same biomaterials in order to integrate into the 3D printing system. So this is an earlier work of ours. So I guess our next step would be using the same materials, using this biomaterial 3D printing system, integrate into the robotic system, and try to see if we can do the 3D printing directly from our robotic system, which will give us capability to build more complex and large-scale coral structure. All right, so going back to later the biology side, I believe Professor Hauser emphasized that we are not really building a live coral. We are building coral structure where we can grow coral. And the leftmost figure is one of the earlier work Professor Hauser's group did the 3D printing. And then once you do the 3D printing, we can actually attach the live fragment of the coral. And over time, it grows over the structure. And this is a different type of experiment Professor Hauser lab did in the past. As you can see, as you first attach a small fragment, and then it grows over the 3D printed part. And eventually, this can be used in the field as well. Okay, this is a short presentation. We just wanted to showcase our collaboration to the conference attendees. We want to give a special acknowledgement to the team members, both in Professor Hauser's group and my group in the RISC lab. So students did an amazing job, really amazing job to make this happen. I also want to thank our supporters and collaborators who's been helping us with getting to this point. All right, thank you so much. And the other thing is we are going to keep this video running throughout this session. So if you are curious how things are working, just feel free to stop by in front of the main monitor. And also if you have any questions, please let us know. Thank you so much for your attention.
Thank you a lot for the amazing presentation.
Thank you for your talk. Will these corals that inhabit the structures that you're printing be able to survive better than the corals that are currently bleaching?
Well, that's what we obviously hope, but we need to work together with the real specialists. So this is just a very multidisciplinary process where we need the technology, the material, the biologists, because obviously even the corals which we then use the fragments, we have very carefully to select for it because they have to be resilient, temperature resilient. We know the temperature are rising. So there's a lot of different points which needs to be considered, obviously. Yes.
Thank you.
Thank you for the presentation. I just am curious, how quickly can you print a coral and what size is it?
Currently, it really depends on how fast we can move the robotic arm. So that's kind of limitations. So for instance, if you can imagine that is a very, very small size of the 3D printed part, and it took about 1 hour. So one direction we are trying to see in terms of the robotic research is to see if we could expedite the system. Either we integrate the more robotic arms so they can work together, or we could find a way to split the models into small fragments, so we can do the parallel printing and then use the robotic arm to put together. So either way, we are trying to see better way to do the 3D printing and then expedite the process of building the coral structure.
Okay, so something, I'm a coral restoration practitioner, so right. Utilizing these for the next steps. How scalable is this to go to something that will make an impact in our large coral restoration?
Right, that's really important questions. And unfortunately, at this point, I don't have clear answer for you. I think it really... Okay, so it looks like a Professor Hauser has an answer. But when it comes to additive manufacturing, it's not just releasing the material. You have to look at really the structure. So it depends on what kind of coral model, the structure you have, and you have to look at whether we can just build a large structure of the coral using the robotic arm, which allows robotic arm itself has a capability to do large scale 3D printing, but it's really the structure of the model we are using. Do you want to give an answer?
Yes, so that's correct. So the printing by itself is difficult. I mean, to scale up in a huge on a big scale, upscaling it as of this moment, and maybe in the future that can be reduced. But I was not able in the shortness of time to got into this one that we can also print molds, and that is an easier process. And we still would need to look for the structures and use them as of going here along that we do actually taking cheap molds This is here, molds from the printed structure, not doing the regular way of printing then the structure like this, but molding it and then having hundreds of molds and big sizes or whatever from a cheap material like silicone, etc., and then use the specific CCP ink, which is the same what the corals are made of, and do then molding. So that is at the moment a hybrid process, you can call it. All right, but obviously doing printing only in a better speed and a more fashionable way would be desirable. So we're working on both sides, but we have a solution already.
Great, thank you.